The next thing we have to build is the cap and the threading part. Let's start with the cap because that one is the easier one. And before I do this, I actually go to layer 1. Here we have all our previous rings that describe the proportion for our bottle. And I can actually simply select a ring. The cap is also tubular. And then go to the front view with 1, Shift D and Escape. So we made a copy because when you press Shift D, you're immediately in move mode. And when you press Escape or right mouse button, you kind of accept the copy command without moving actually the object. Now I have to adjust the size a little bit. I can press N, then I go to dimensions and, for example, type in 38.2 millimeters and 38.2 millimeters. Okay. Now this one I have to move up by roughly 10.8 millimeters. So I could press Shift D, Z. You see now I can move this one up. So I'm in move mode. And then I type in 0.0108. So 1 centimeter and 0.8 millimeters. And in case you typed in the numbers incorrectly, you can see you can still go with your arrow keys and go to the different decimal positions and then adjust the value accordingly. And press enter, and there we are. Good. However, problem right now we are going to see is there are a lot of curves, and to me at one point it's difficult to understand or to visualize which curve is actually from what object. So I select these 2 rings, press M, and in my case I simply put those profiles onto the layer below. And then you see this way you can easily switch between the different sets. And I use layers actually a lot to logically separate different parts and modeling steps. Okay, next step. Design-wise, there's actually a line that comes down and then at one point it bevels out slightly. So we have to build now this part where the metal is folded kind of like into a rounded shape. And we have an upper edge that is 2.3 millimeters high. So what we can do now is press Shift D, Z, .0023. Let's make 2.5 easier steps and press enter. Okay, perfect. And now I would like to have 2 more rings that bevel out, or 2 rings that are larger that kind of like describe the rounding like in a box. So I Shift left mouse button click the second ring, press Shift D, and for example what we can do now is there are 2 ways how we can scale these objects. So I'm in move mode, but I don't want to move, I want to scale. So well, I just press S and now I'm in scale mode. The problem is if I scale now, let's go to a side view, you see actually how they are scaled towards each other in a way and along all 3 axes. That's not really what I want. So let's undo this one, Shift D, S, and then to restrict, for example, the scale along the Z-axis, I just would like to scale them along Y and X. I simply press Shift Z, and then you can see with my mouse moving it, I can scale it along those 2 axes. And then I only have to pay attention to the value inside my dimensions field. And when I hold Shift and move my mouse really carefully, you see I can actually scale it in very small, fine increment steps, and left mouse button, and we're done. Perfect. Also a small tip, so when you scale, and you see actually where my mouse cursor is and the dotted line. Now that's kind of like the distance. And the smaller the distance to these objects, or the smaller the distance of the cursor to the scale center is, the quicker you scale. Let me move my mouse actually far away to here and press S. And you can see when I move my mouse, the scale effect is a lot slower. If I move my mouse to here and press S, it is a lot quicker. So whenever you scale something, move your mouse a little bit away, and then you have a better, smoother scale effect. And the same is pretty much also with rotate. If I go really far away, I have more screen pixels that can describe actually the rotation. If I get closer, then I rotate much quicker. You see, like, every screen pixel is actually a huge jump in the rotation. And here, every screen pixel is a much smaller rotation. Okay, let me show you step 2, how we could scale something. So U and U, Shift D, press Enter. So now we made copies and placed them there. We can, for example, here type in 40.5 millimeters. But the problem is it only adjusted one object, the blue one, not the white one. So what's going on here? In Blender, when you select multiple objects, you always have selected objects, and the last one, the blue here, is your active object. So this adjustment in the dimension is only applied to the active object. However, when, for example, we press and hold Alt and then click on the field, release Alt, and then type in 40.5 millimeters. Oh, what happened? Hold on. 40.5 millimeters. There. It adjusts actually for both. Let's do it one more time for Y. I press and hold Alt, click onto the Y field, release Alt key, 40.5 millimeters. Oh, I love this demonstration effect. Let me show you a second way how we can do the scaling. So I select these two objects, Shift D, and then Shift Z, S, scale it a little bit. Okay. And now here, for example, I type in 40.5 millimeters and 40.5 millimeters. And you will notice that actually the blue object got scaled, the white object did not get scaled. So what's happening? Blender kind of like, let me say it this way, you can make a selection, but always the last object you selected is kind of like the active object. So all the values we type in here this way are only applied to the active object. However, what we can do now is, with Blender, with the blue ring still being the active object, we could go to Dimensions, right click, and then say copy to selected. So what will happen is actually the white ring will copy the scale value or the dimension value from the blue object, so the active one. Make sense? There. So for example, to show you how this works, I can also make some copies. And now I select my target. Think about the active object also as the target. So from this target object, I would like to apply or copy the dimension to all those white objects. And then I go right click, copy to selected, and they're all scaled. And that, for example, also works with the positioning and rotation, etc. Okay. Now, the next step is actually, there is a small dip in here. So let's select this ring, Shift D, and then let me quickly measure that distance. So for example, I think this one is roughly as it seems, yeah, 30 millimeters. Okay, press enter, go to transform, and then we say here 30 millimeters and 30 millimeters. Okay, and then everything sinks down just properly a millimeter. Yeah, roughly millimeter. Okay, so Shift D Z minus 0.001. You see with the minus key, I actually flip the direction. So instead of moving it up 1 millimeter, we just move it down 1 millimeter. And then we can press enter. Perfect. Okay. And then there's also a small ring or radius actually. So I go to here, place my mouse cursor with Alt right mouse button, Shift S, circle, and then I can press F6 to get the command for the add Bezier. By the way, actually this pop-up we can also find when we go and press T. Maybe let's move this one down in case it looks like this. Just move it up. This is basically exactly the same information. This is when you press F6, it's simply a screen overlay. And the radius is roughly 2 millimeters. Sorry, the dimension. So here we just type in 1 millimeter. And I would like this to be rotated 90 degrees along the x-axis. Let's zoom in a little bit, and there it is. And now I can move this one up along the z-axis and then hold Control key and snap to this point. And for example, I could press G and X, so I move it left and right and snap to this point, or I click on the red arrow, hold Control key and snap to this point. Okay, so this kind of like will help us a little bit to understand how, for example, the edge rounding up there has to look like. Okay, so I think let's go to top view. This object is completely misplaced. We have to move this one up. So it is kind of like along the x-axis, and that means here the y-axis has a negative minus 3.5 centimeters. We simply type in 0. And there we have it positioned perfectly. Okay. Now, we have to add a new spline node so we could draw a side profile. And that 3D cursor right now you see is misplaced. So what I'm going to do is I select this ring, which is perfectly positioned x and y to 0. Press Shift S, cursor to selected. So you see I have the height and I have x and y perfectly positioned. And then we can go Shift A, curve Bezier, 7, zoom out a little bit, press Tab, and scale everything down. I would like to turn off the normal view, so let's turn off the normals. And then, for example, we can select these 2 points, press V and say vector for the moment. And then we can start like what we did before, moving these points roughly to where they should be, and then with Control key, hold on to it. I'm actually not snapping to this point. I'm going to snap height-wise to this point, and then I move it along the x-axis to there. And then I press one more time E and Z, and I actually snap to this point of my ring. And then I press E and snap to this point. So pressing Control obviously. And then I press E and X, because now I'm in 3D view, Control click to there, E and Z, Control click to there, E and X. How do we find the midpoint? That's actually where our 3D cursor comes in handy. Set to 3D cursor, and then we could say SX, so scale along the z-axis to 0, and it's centered. There you see it. Let's do this one more time. So when I press S and X, I can only scale along the x-axis. And you see with having the 3D cursor being the target, and we press 0, it scales to the target. And 0 basically is at the target. Let's position the 3D cursor somewhere else. S and 0, and you see there it actually moved it to that 3D cursor. Obviously that's not really what we wanted. We can also actually here type in 0. So you see there are always multiple ways how you could do it. Okay, so these 2 points, for example, we're going to turn into, let's say, aligned. And you see already it looks like a nice, nearly nice rounding. So now what we can do is switch back to the bounding box, adjust these handles a little bit. There. Now this looks actually a little bit better. For example, down here, this isn't really as stepped, so we could sculpt this a little bit more. These 2 points, for example, we select and say aligned. Oh, look at this. So we have a nice S transition. This looks pretty good. Let's go to here, U2 as well, aligned. Well, it's not going to do much. So I select these 2 points together. And, oh, what's going on? Why don't you... I see, okay. They're aligned. So what aligned means actually, this point is aligned to the vector or orientation of this line. So if I move this, no, there it doesn't work. Oh no, wait. They weren't really set to vector yet. Oh no, something is odd. There. Oh, I'm silly. Yes, aligned. It needed to be free. So when this was vector and this was vector, obviously then these 2 that can't be aligned. They have to be free because then yeah, I can freely move them. Well, my fault. So I moved those actually maybe till there, and then with these 2 points or handles still selected, I can press S, and look at that. I can actually scale them away from each other. And then this one, I move up along the Z and snap to this point. I move down and snap to this point, height-wise. And then maybe I can actually adjust this a tick more there. But this is not really, for example, a good transition. So, that's not a big deal. We can fix this actually when we do the polygon model. Maybe push this out a little bit more. Okay, good. Maybe preview this for the moment to see how this looks. Make a screw object with 64 versions. And maybe let's show me the bottle as an overlay. Yeah, that seems to fit. Good. And then we can turn this one off again. Okay. Let's go back to here. And so what's the next step we can do? Okay, so let's do exactly the same approach how we built the bottle. So Shift S, cursor to selected, so it is at this center, and then I'm going to add now a plane. So Shift A, mesh plane, F6, 1 centimeter, so the plane isn't as large, and then can go into edit mode with tab, maybe switch to vertex select, scale this up a little bit, and then we can do Control R, click and return, Control R on this edge, click and 0 return. Oh, you saw actually what happened there. So maybe this might be good to warn about this behavior. Every time when you press Ctrl R and then left mouse button click, you should not move the mouse, because by accident you will adjust or you slide this edge. To really be sure that you place it perfectly at the center, simply press 0 and return. So why 0? That's very easy to explain. 0 is simply the mid position. And check out this number. Under my cursor, it's 1. And that's 0, and now it's -1. So this is basically -1 is the right, 0 is the mid, and 1 is the left position. So 0 is the midpoint. Okay. Then we can select all these points with Shift and left mouse button click, or we can simply select the 2 points we want, and then we could go and say select inverse there, Control I. That selects everything else, and press X and delete there. And this point, for example, we move over to there. Okay, and then here E and Z, snap to this point, E and X, Control, snap to this point, E and Z, let's go to there. Actually, hold on, we go till there, E and X. Here we will sculpt this later a little bit, there, E and Z, snap to this point, but then I move it over to there, E and X, and then also here we type in 0. There's no actually or very flat polygon model. This part I would like to be on layer 5, so I press M and 5. There, perfect. Now actually I can, for example, also here add the screw modifier. And you might actually ask yourself, why do I use 6? Let me actually show you something. This will explain it very good. So here is a plane. Let me open this one and close it. Okay, now we have an open rectangle. I'm going to add a circle now as well with 6 points. Okay. Now I select this rectangle and say subdivision surface and 3, and the same here and 3. And maybe in the first moment you would say, yeah, I don't see a difference. They both look like circles. However, take a look at this. So if I take the circle and scale it up a little bit, you will see actually that the 4-point ring turns not really to be a smooth circle when we smooth it compared to the 6-point ring. So that's one of the reasons why, for example, I do not do tubular objects with less than 6 points. The other advantage actually of 6 points is simply this. I could delete these 2 points. Now I have an arc. I could add actually a mirror modifier, add this mirror modifier on top of the subsurface, and I have a ring again. But I actually only work on half a model. And that's simply because with 6 points you have along the mirror plane 2 vertices. So in case I would slice this model apart, maybe let's go to here. Let's select all this and delete it. Now our object is open, and then I could add a mirror modifier, move this one up, and say mirror along the y-axis, and there we are back to a full object. And this, for example, is very helpful when you would like to explore some sculpting variations. So you see I just worked on one side of the model and that applied it to the other side. So instead of working on each side the same way, then it makes sense to just simply cut your model, halve it, throw the other part away, add a mirror command, and then you continue working. So let me undo this step at least, and the rest, no, actually, hold on. I would like to have a full model again, so apply modifier, and then I have a complete model again. Everything is back. Perfect. But what do I see down there? Is everything fine? Yeah, yes. Okay, good. So let's go back to our cap. So this is kind of like our basic object, and then we just simply click apply. You will see that oddly the mesh is kind of bluish and the inside is kind of silver. Specifically, this will be more visible when we add a subsurface. So what does that mean? Let me introduce you to what we call surface normals. So let me go to face select. Maybe I select this face or this face, and then I go to the property panel and I go to mesh display, and there are normals. 1 centimeter, and I turn this one on. And you see all these blue lines. Now think about a sheet of paper. You have a top side and a bottom side. And this is basically what indicates the top side. And blue is always the color here for the bottom side. Some other programs, for example in Fusion, yellow is the inside and silver is the outside. And the outside here is blue. And that means currently this model is inverted. Nothing really we want, so we are going to flip it. To do this, we in edit mode select everything with A, and then we can go to the tools section, and let me see where this is actually here. I think under shading and UVs, flip direction, and there. So now they all face outside, and there, perfect. Let's say, by the way, you have actually something like this. That's an artifact, because you see some faces look to the outside, one face looks to the inside. What we can simply do to repair this, select everything and say calculate, and then it actually normalizes so that all faces look to the same direction. Okay, good. Let's remove all this, and I would like to see my bottle now. Now we have to actually adjust again the dimensions a little bit. So with everything selected, let's see what we can do. We're going to do the following. I would like to have a sharp edge actually along this edge. Let's turn the normals off for a moment. And I'm not going to add actually a bevel modifier in this case. I'm actually showing you what edge creasing means. So you see here I have mean crease. With the bottle we use the bevel weight, and we can do the same for the subdivision surface modifier and weight an edge. And you see the more weight we add, the more it creases until, for example, it gets pretty sharp. There. I can do also the same and the same for this. You see, for example, now we actually got a really sharp looking model. So all these edges are very sharp. Make sure they're really one. Sometimes it's better simply to enter it with your key command. And maybe we do the same here, there. Okay, so I'm going to turn on optimal display, so my wireframe mesh is a little bit less dense, and I better see the boundary shape. Then I can go into the view with my the rings for actually the cap. Go into edit mode, AA, so I select everything, and then I press make sure that this is set to boundary box, S, Shift Z, and then actually I scale everything away from the Z center till, for example, it hits the proportions we actually set up first. And there we see, here we might have to S and Shift Z, scale those back a little bit, or tick. Okay, good. So now we can actually be a little bit creative with the way how we style everything. So this edge I'm going to soft, and actually here add a crease again with the bevel command. So let's move this one up 1 millimeter, maybe 5 there, and the weight only. And let's see how this looks. So maybe we set this to a 0.6. Okay. And 0.6 is maybe a tick too big, maybe 0.5. Let's maybe keep it there, and you see that there is something odd happening. This is all flat and then it bevels in or it dips in. So what we're going to do is we add with Control R another loop cut and move this one up. So what does that mean? That's simply, how could I say that, stabilizing or straightening the faces along this line, or basically between these two rings. Because essentially what the subsurface modifier is doing, it is softening everything. And whenever we have, for example, multiple lines together and they are parallel, we straighten a surface. Okay, so maybe I need to add also one up there. And then I can, for example, move this one and see how far this has an impact on it. And maybe leave it this way. Now maybe down here, let's try not to use the bevel command and actually sculpt everything by hand, just with loop cuts. So these rings I actually change back without any creasing. Let's take a look. And first thing to do is add a loop cut and move it down. So you see now with the loop cut, I'm going to straighten that vertical face and tighten that radius a little bit. There. And this doesn't really look very circular, and I think in the actual model it's also not really a circle, but it's a little bit rounder. So what we can do now are two things. We could either select these two rings and then S and then Z along the Z axis, scale them towards each other, and then you see actually this starts looking a little bit more circular compared to this. And simply what's happening here is, if you think about these points, they start looking more like a half circle. So obviously then the smooth result will look slightly more like half a circle or a bent circular shape. And Shift S and Z, and let's scale those down a tick more, because what I'm curious about is what happens if we then move this one up a tick. There, and there, maybe this down a little bit. No, let's leave it. Okay, kind of like this. But actually the metal there is folded in a little bit, so what I'm going to do is I'm going to select this last ring there, and then I press E and maybe G and Z, move this one up. So you see now how the metal comes down and then bends up a little bit. And this is actually, I think, bent inwards a little bit. So now I can, with S, make this ring a tick bigger. You see how the white ring gets slightly bigger in diameter. So this actually folds in. However, you see actually that the lower edge is higher now. So in this case, for example, what helps is turning off the bevel command, because then I can see how the mesh cage looks like. And I'm going to start and select, for example, those lines and then move them around and adjust everything a little bit so that I actually get back my original proportions there. I have to scale this one a little bit there, and then this one has to go down a tick more or scale a little bit. Yeah. For example. Now this is actually really tight, so let's take a look at that object, if maybe we couldn't do this a tick better. So maybe just one line here isn't enough. Question is maybe, what happens if we do something like this? G and Z, and then scale and Z. Because what you want is that those lines try to be as evenly long. So meaning that those rings are at even distances. Now you see actually, yeah, this looks much better now. But I might have to adjust now the whole design a little bit more. So this one maybe move up there, and then U, S, and Shift Z, move it all inwards a little bit. Again, then U and S there. The lower part S. Yeah, there we are. That's okay for a first test. Perfect. Okay, so we can turn this one back on. So we see, for example, this edge. And up here, I'm going to be lazy. I'm going to simply crease this maybe with a 2/4 value. So like 0.25 millimeters edge rounding. And that seems to be pretty okay. And let's say maybe 0.5, how does it look? Yeah, 0.5 is getting too big. Parts are intersecting. But actually with a 0.4, that seems to work out pretty well. Let's maybe make a cross-section view. We can do this by pressing and holding Alt and B and then drawing a selection. And we can actually see how the surface looks. And then to get out of this view, you see this is actually clipping border. We simply press Alt B again. You can also do Alt B from here. And we just see only this part. It's a really nice way when you want to see cut sections. Okay, I would say actually we are nearly done. Maybe what we can do in this case is add a solidify modifier. This is now metal, so this is actually pretty thin, not thin, and maybe 0.1 millimeter. Okay, even thickness, and we can leave it for visualization purpose. This way, we don't really have to do much more. Okay, so this is basically the cap. As you can see, I also have renamed the model to cap, so I can easily find it, and we're more or less ready to start working on the threading. Let's start with the bottle, and go to the bottle layer, then shift click layer 6, and I make sure that my 3D cursor is nicely positioned along X and Y to 0. That's perfect. And then I can, for example, press Shift A, add a plane, F6, let's see where it is, okay, and there is my plane. I can tap to go into the edit mode, press R, X and 90 to rotate my mesh along the X-axis by 90 degrees. And then I can move this one over a little bit, and for example to there. Now the threading has a height of 2 millimeters and it has a width of or like a depth of 0.5 millimeter. So before I measure all the stuff, what I quickly do, I go into object mode, scale my object to 2 millimeters, and my dimension, this is X here, to 0.5 millimeters. And then I go to object and say apply scale. And then I can move everything back to where it should be, roughly there. Now most programs for engineering purpose have actually dedicated threading tools. You do not build the threading, you simply mark where threading is, and then later a machine cuts it. Now in this case here, where we have a glass body that's casted, we have to sculpt the threading. And everything what we do right now is because it's not necessarily machined that way, we just build it, we can also be quite creative with it. So kind of like build the own threading mechanism or look we really want to have. So with this part designed, we can maybe move this up a little bit. And this bottle has actually a threading where you have to the front, back, left and right, kind of like a line going down at a slope. And so now how do we build the threading? This back edge here, I'm going to delete. And maybe this line, I'm going to scale down a little bit. Okay. Something like this. And I start with very simple geometrical shapes. And you see then always step by step, I start adding refinement or complexity to it. So we would like this actually to spin around the bottle. And yeah, we can use actually the screw command for that. And guess why the spin command here is called screw and has the icon of, well, a screw, because this is also the tool we can use to make threadings. So I'm going to set this one to 64 for the moment. Now this goes actually completely around my bottle. Okay, so do you see here, there is screw. What happens when we type in 2 millimeters? You will see actually that my object has a height of 2 millimeters. It screws it 360 degree, one iteration, to a distance of 2 millimeters. If, for example, we set 2 or more, you see actually how this continues. If now, for example, we say 3 millimeters, we have 1 millimeter of a gap in between. So very simple actually to create custom threadings this way. Now, because this all is based on kind of like this polygon model, or in engineering terms, sketch, when we scale this one, you see actually how the complete threading adjusts. So this is pretty awesome. Now I mentioned before actually that this threading has 4 small segments. It's not really like a complete threading like this, so we only have 1 iteration. Okay, and maybe the angle is actually pretty high, so it starts nearly at the top and goes down to the bottom, and I think there's roughly a millimeter distance from the top down. So let me check. No, actually 3 millimeters. Okay, so let's do this. So 360 degree is completely around, and that's not what I need. I need a quarter rotation. So 360 divided by 4 for the lazy people is 90 degrees. And now I can, for example, visualize this a little bit better. No, unfortunately, this is not at a front view. It's kind of like a quarter view. So this object, I'm going to, in top view, rotate by 45 degrees minus. Could also simply type in 45 degrees here in rotation. And then if I press 1, I have the threading right in front of me. Perfect. Now I can move this one and line it up roughly so it's at the top part. And I said it goes down 3 millimeters. So I could either, for example, here now say, so this is, let's say 15.6, it's 3 millimeters, 15.3. And we just move the whole thing 3 millimeters down. Okay, that's good. But this one in the actual design also sinks into, so the threading doesn't stop on top, it really flows into it. So we might actually have to adjust this one a little bit so we get a better, a better or stronger slope. So let's do this again. Hold on. This actually, no, I lined it up, and now I have to move it down 3 millimeters because with changing the value here, I changed the height. So GZ minus 0.003. There. Okay. And there you see actually that it is pretty much stopping right after it. Well, this is really 3 millimeters. That looks a little bit too strong. Let me measure this again. Nope, it's actually not 3 millimeters. My caliper was incorrect. It is actually 2 millimeters. Okay, so GZ .001, 1 millimeter up. Okay, unfortunately this piece sticks out again. Okay, 5 millimeters. There, GZ minus .002. Okay, pretty much should do it. Let's be really precise to make sure that it really intersects correctly. So from this view with Alt B, let's make a cut section view so we can see, yep, the ends actually go through the part and the rest inside the model. So that is perfect, because that's what we need. It doesn't have to rest on the model, it has to cut through it and stop inside. Okay. Now this part, for example, we could duplicate 4 times and then rotate it each 90 degrees. So instead of making Shift D, I'm going to use Alt D because I'm going to make clones. So Alt D, and then I type in 90 degrees. And hold on, that was kind of stupid because I should have pressed Alt D, R, and 90, because I just made a copy, a clone, and then I moved it by 90. So Alt D, R, 90, Alt D, R, 90. Okay. So when we take a look now from the top, we can see that actually each threading stops right at where each other threading stops. And that is actually not correct according to my part. So they're actually bigger than 90 degrees. So let's see what we can change here now. So I select all these 4 parts and I'm going to adjust this value here. But if I type in, for example, 100, well, let's say 120, so we will see everything better. Just the blue one got changed, but not the rest. So what we do actually, you hold Alt key, click into this value, and then type in 120 and press enter. That actually applies the 120 degree change to all objects we have selected. And take a look at this. Yep, this is better now. We see actually here there will be an interlocking mechanism. This is exactly what we are looking for. Pretty good. Yeah. So let's see, maybe should we do something with the shape? Another demo to show you actually what the whole idea behind clones or Shift D and Alt T is. Now they all use the same mesh. You see here plain mesh 4. Let me, for example, type in threading mesh so you understand what's happening. But this is, for example, plane 05, plane 04, or 3. So you see those are different objects, but they all actually use the same mesh information. And that is basically what happens when you use duplicate linked or clone. So they say linked because each object is linked to the mesh of the object I'm making a clone from. So advantage of this is I can select every object and, for example, modify the mesh, and then yeah, all other objects that are linked are updated. Okay, let's undo it. And I would say we are pretty close to maybe start adjusting this a little bit more and sculpting it. Maybe I would like to change the radius a little bit more. Instead of 120, Alt click 140. Yeah, we have a little bit more of overlap here, a longer distance, so we can have a better and tighter fit. That is good. But also our threading isn't really resting perfectly, or not resting, intersecting with the bottle. So what I'm going to do here now is the outer points are more or less okay, but maybe these points I would like to move in. Now you see now if I press Y, or move it along the Y-axis, it goes straight down, but I would like it to go to the center. And last class I talked about global and local. Take a look at how, for example, the axes for the X, Y, and Z manipulation change when I switch between global and local. So let's go into top view, Control Z, undo, and there you see now I can move these 2 points along the x-axis perfectly towards the object center, because I also had the object rotated a little bit 135 degree. See, when I go to this one, it faces to its unique orientation. Okay, so this way I can quickly adjust the mesh so that it intersects. Let's double check a little bit. Yep, it does, so that's good. And hold on 1 second, one last double check. Yeah, looks so. Okay. Visually, sometimes this can get also a little bit confusing when you have many objects. So what I sometimes do is, I call this one maybe modeling. And maybe make this one slightly bluish. So that it simply has like a visual code. And then maybe those, maybe I call, because later I will add those parts to the geometry, I call this Boolean, because volume wise I added there. Now this is actually, for example, much easier to read. If I make a cut section view, also there, much easier to see where mesh is intersecting what where. Perfect. Okay, so this is pretty good. So this is now the kind of like the basic threading. I just figured out the layout, but the threading isn't really finished yet. Specifically, it looks pretty wonky and it's open. So I have to go and refine this now. I can select this part and then Shift D, so I make a copy, not a clone, and maybe move this onto a different layer, layers 7 in this case. And let's go back to the screw command, maybe 32, let's see, no, what about 12? We can simplify this a little bit, and then we also add the subdivision surface modifier. Okay, let's take a look. Where does the mesh actually start? Not there yet. So I'm going to undo this one. So my threading is rotated not along the Y as a Z axis. So the end cap is actually lined up, not perpendicular to me. So I can better actually, for example, guess maybe the distance. So what is this distance? Let's measure it quickly. Let's go to measure, whoops, not this one, there. And then left mouse button click and drag and release left mouse button click. Okay, so 5 millimeters. So roughly this grid line is actually where my mesh at the end has to be. To exit this command, press Escape, T, and for example, we could pull this one out a little bit there. So this now, the threading has more the kind of like the depth of 5mm when it comes out of the glass bottle. But 12 steps is actually a lot. So what about 6? I'm trying to simplify it. And you notice what happens when I simplify it with less steps. We are losing our width a little bit. So maybe 10. Let's see. I'm going to quickly apply, going to edit mode and see how many steps I have. And that is actually pretty okay, a little bit dense. So I would still like try to see with 6. How does it look with 6? This is a little bit better. Okay, undo, because now before I apply it, I'm going to see how far maybe I could actually push this one out. So you see actually that the ends are sticking out a little bit more than the width. So I can't actually in this case just base everything on this approximation. I might have to eyeball this a little bit. And the threading should not stick out further than, for example, the lip of this bottle part here. So in top view, I can move this one out a little bit till maybe there. Okay, so that probably will be good. So in this view here, I can see actually this is my 5mm, so I'm a little bit over it. So GX X twice, so I move it along the global one. When I'm in that view I can't do it. That's funny, because I was actually looking along the the x-axis, so I couldn't see it, but there, I'm pretty close. Okay, again, this is not very precise, but all we do here is sculpt actually the looks. Okay, good. Now this is actually something I like. I'm going to make myself Shift-D a backup copy and M and place it below in case I have to go back to it, and then I'm going to apply my screw modifier. Okay, so now you might ask yourself, well, what was all this about? So this one I move in a little bit just to be sure, and we have to change the way how this looks. Let's say I would like to have a little bit of nice sharp edges. So I select all these loops and then, for example, I crease them. Take a look at this. No, this is not too bad. Actually, this and this maybe I do not want. There. Okay. Now what I can do, and that's a nice thing about this type of working. Let's go to local. You see, if I go to local, if I go to global, it doesn't update. So what do? Not a big deal. We're dealing here with a circular object. So instead of actually using global or local, what we can do is we can scale to our object center by using the 3D cursor. So what I'm trying to do now is very simple. I'm actually maybe selecting these 2 points, and then I say scale, Shift Z, so excluding the Z axis, and maybe make this a little bit more narrow. And then I select the next 2 points, S, Shift Z, and scale this towards the object center till it starts sinking into the object. And then you see how the threading actually comes out the body, and then down there goes back into the body. Pretty awesome, not too difficult. And few other things we could do. Maybe here, if we want to, we could actually now go back to the normal mode. So S and Z, for example, we could tighten all this a little bit. S and Z, tighten this a little bit more. S and Z, S and Z. No, I made a mistake actually, because you cannot scale those two together at the same time because you flatten it. So what I'm going to do now is actually pay attention to the top. So for example, I go to 9. Okay. Maybe make this one 9. So kind of like a 10th. Okay. Maybe let's say 9.5. Then this one is going to be 9 over there. And this one is 8.5. There. And then we go back to the 3D cursor and S, Shift Z, scale this one in, and select those, S and Shift Z, and scale those in there. So by having scaled actually the cross sections a little bit, it's not only that because this one is moved in, the threading comes out, but the threading starts also a little bit thinner and then gets bigger and remains then the same thickness. Okay, perfect. Now this object, for example, we can make clones of again, because this is now our sculpted threading. So for example, I call this one threading sculpted. And I really can put an emphasis on name your objects, because later it will become really annoying when you have to look for circle, cube, plane, .001, and you have to remember what object actually those are. And having a proper naming makes it a lot easier. So Alt D, R, and 90, Alt D, R, 90, Alt D, R, 90. And there we have actually our threading repopulated. So why, for example, did I give those names? And because I mentioned later for selecting something it will be a lot easier, because you would say, well, you could visually just click on them, so what's the big deal? Let's save. Let's go back to here. Because this object does not have the threading. We are going to add actually now the geometry. So instead of modeling the threading, maybe what you would do if you just would like to make a polygon model, we actually use Blender to sculpt shapes, so we later then bring it into Fusion and then glue all these parts together. So the way how I teach modeling in Blender is borrowed again from the process how you would create surfaces or objects in Alias and Fusion. So the workflow has to be the same. So we can select the model, go to the modifier. To make everything a tick faster, I just changed this to 2 for the moment, and I turn this one, I leave this one on. And then I go to the modifier and say Boolean. And then difference, no, sorry, union. And then here, for example, now I can type in threading, and there it is. Let's do this one more time. And threading, but the second one. And you see it added actually the second one. So if I go into wireframe mode, you will see actually how this geometry was added to it. And if I switch view here to 2, the results will be a tick better. But the higher the view level, the more polygons they are and the more the software has to calculate, so the longer actually the delays are. So try to keep this always at a 2 or 3. Never go to 4, 5, or even 6. I could, for example, now simply add the other missing 2 threadings. I'm not going to do this because then later this tree will be very full. I call this, for example, threading. By the icon I know this is a volume operation, so I'm adding something to it. So I go back to here and select my threading, and then there I actually say Boolean union U, and then one more time union and U. There's actually, you see an eyedropper you can click onto, and the last one. Okay, so you see now I have my individual objects and the first object, so the threading with all the other parts added to it, because that actually makes life a lot easier to update this one, turn this off, turn this on, and there we have the threading added to it. Pretty perfect. The nice thing is, for the sake of demonstration, those are all actually clones. If I go ahead and, for example, adjust the geometry of one and then leave it, the geometry of all are changed, the Boolean result is changed, and one moment, this model is changed. So you see this is actually very interactive. It's also called non-destructive because you basically work with calculations and you can add elements together, cut elements, remove elements. And that's kind of like the way how you want to work, because something is more annoying when you have to change something and then you have to redo from scratch. I mean, restart from scratch. So because we have figured out actually those threadings, and we now can do the threading for the cap, and thus, as you can see, I deactivated those Boolean commands. Simply, all the time they're on, that will be calculated, and I can slow down Blender with complex models quite significantly. And for me, visually, I can simply turn this layer on with the threadings on it, and then I see kind of like the shapes. So I actually noticed that my cap is a little bit incorrect. This actually doesn't sit that high. The cap actually sits pretty low. So I moved everything down a little bit, as you can see. Previously it was more up there. And I actually would like to see through my cap as well. So like half of this bottom part I would like to remove. So what I can do in this case is the following. I'm going to add a cube, scale it down. In object mode, that's fine, till maybe there, and maybe move it to there. Can go into edit mode, move those back up to make it a little bit smaller, and maybe also here from the side S and then Z, scale it down. Okay, and it's important that actually the cube, as you can see, is not at the center. It's a little bit below or a little bit above. Let's actually go to there. And this cube I also rename cap cut section, and if I want I could just give it a color or leave it. And yeah, so why? The main reason is actually now with this cube I can cut this one area out. But you see I gave everything the colors, but this cube is visible all the time. I can actually simply go to the object properties, go to display, and then say, well, instead of showing me it shaded all the time, just show me it as the wire model. See here, for example, if I turn wire on, there's just a wire model. So I am actually in shaded mode, but it only shows the polygon mesh. And that is very useful because now I can add a Boolean modifier and say difference, eyedropper, that's object, and it cuts it out. And I can actually move the cube and then always have an updated cut. And this, for example, is very useful when I now turn on the bottle and, for example, I turn on the threading, because I can pay attention to the space I have in between. The cube is a little bit in my way. So I'm going to move it onto the layer below, for example, where my cap is. So M there, and then I move the selected cube object to that layer. And even when it's not visible, you still see it actually cuts the geometry out. Now the threading for the cap is actually a plastic inlay where we cut the threading actually out. So this is going to be very, very easy to build. So what we can do is make a new plane, but again, before, make sure that your cursor is XY at best 0, the correct position. So Shift A, plane, and then tab to go into edit mode, have everything selected, RX 90, and now we can actually start sculpting everything. And maybe move this one over, move this one down. And you see I try to prevent by hand moving those. So I don't want them crooked. I want horizontal lines horizontal, vertical lines vertical. This one maybe to there. This one maybe a little bit to there. Let's go actually top view. There. There is actually indeed a small depression, so it follows that part. So in this case, let's hide the bottle. So this one goes down a little bit. X. And here you see, for example, this line, how much it intersects the threading. So this line probably can be pushed a little bit closer, and this can actually be pushed closer down because that layer will be compressed and it's going to seal actually the bottle, so no fluid will come out. This one can go up a little bit, maybe to there, and then maybe let's move this one over. Let's move this one up. Actually, this we get really close. No, what we're going to do here is actually more something the engineer would do, but we can simply still make a quick mock-up. So as an idea how something should look, for example. Which also means for us, we don't have to be insanely precise or accurate with our design, which is also sometimes a bonus. And now I have this geometry here and I would like to capture it. But now I have this other part and I need to match it. And you see this is actually maybe turning a little bit into a tiny issue for me. Specifically, how do I get this radius up there exactly the same way? So what are possibilities maybe I could do? And this is actually what I'm going to do now. I'm going to use this shape, make a copy, and then I apply nearly most of these modifiers. So I have more geometry I could work with. So let's do this, Shift D, and we made a copy. Then I'm going to apply this one, because now we have actually this bevel. Then I'm going to not apply the subsurface, I don't want that, but I'm going to apply the solidify modifier. Now you see I also have this inner geometry. This is exactly what I was looking for. And at this point now I can, for example, select one edge here, go select loop and say delete vertices. And the main reason for that is, I think if I did everything right, I can select this one, go to and press L with my mouse over it, and it's all selected. Why? Oh, I see why. There, this is connected. So we have to delete this, delete edges, not vertices, go to here, L. Now you see it only selected the top geometry, and that actually I can simply now delete. Zip, gone. And maybe this one and this one we delete. And then here, this inner loop I would like to select. Sometimes you see actually I have some issues selecting the cuts. Then maybe you can turn this one off, then you can much better select through objects. This actually prevents selecting through an object. This we delete, and you see we have now this left over, and we can delete this. Perfect. Now the Boolean command obviously will complain. That's fine. But what we have now, as you can see, is we have the inner surface that perfectly fits actually that part. So instead of trying to rebuild it, way too much work, simply make a copy and then continue sculpting. So what we're going to do is this, for example, all can go up a little bit. And where is my initial geometry here? There and there. These two objects I like to only see, so I moved them onto a different layer. So I'm going to use layer 8, M and 8, and then go to layer 8. Move this one up and maybe down there. Okay, so this is actually pretty good. And I'm going to make a cut section view this way, because when I actually now select a complete loop, even the stuff that is selected, you do not see, is then also going to be selected. And now I have the ability, for example, to do things like this, remove it, we don't need it. U, then E for extrude, press S for scale, and we scale this one in. And then E for extrude, and then G and Z, just Z actually. When you extrude, you're in grab mode, so press Z to go up. And you see actually down here, this is not very tight, so maybe Control R, one loop cut, Control R outside, one loop cut. I would like these two loop cuts to be at the same height, so I select both loops and then actually make sure I'm not using the 3 cursor but bounding box. Bounding box means it draws a bounding box around your selection, those 2 rings, S, Z, 0, there. Now they're lined up. Pretty good. Select this ring, move this one up, and actually now we can maybe take a look at the bottle where it is, so it will be a little bit easier to model around. GZ, move this one up, yeah, okay. E and S, scale it in. E and S till it hits there. So this is going to be a little bit tricky right now here, because I have to eyeball this a little bit. E and Z down, and S, and then E and S to bring it back in. You see now I built kind of like this area there. So there are now 2 ways I could continue this. This is a deformable part, so I'm not going to round edges with the bevel command for this modeling exercise. I'm actually going to simply work with loop cuts. And because this is getting a little bit confusing, I have on a regular basis to switch between object mode and shaded mode. So for example here we can select this edge, and then again loop select, and I would like to fill in a space, kind of like make a loft. And the command for loft with polygons very often is called bridge. So I can go to mesh, and then I think is it edges or faces, let me see, bridge there. And then it actually bridges the part, and you see now here the geometry is closed. Let's undo it. You can also press spacebar, type in bridge, and there it is. And I think we also have the bridge command here somewhere. I thought maybe, I don't really use this one a lot. I actually memorized all the commands. And then we can select this last edge, scale it back. So for example, it is a little bit perpendicular below it. So you see actually how the scaling of this ring affects the geometry here. Maybe make this a tick rounder there. Okay, so maybe this, for example, we can scale. So we bring this back a little bit because I would like to get the surface. Let's change actually the color. This is really difficult to see there. I would like to get the orange color to follow more the blue surface. And now I'm going to switch to the cage projected onto the mesh. So it's a lot easier now to see what we have to select. So you and you. No, you. What are you doing? Okay, maybe this one. There. Okay. S Shift S. Sorry, S Shift Z, and bring it over. S to make it a little bit softer there. U here. G and Z. Let's bring this up a little bit. And S, tick closer. There. It's a tick closer. Oh, hold on one second. I want to double check something. And they're vertical. So actually I select all those here. There. S and Shift Z till it gets nearly on it. There. And then maybe this one I can move in a little bit. This one maybe move up a little bit or down. There. So you see now actually there the objects intersect. Keep in mind this is a compressible material, so the engineer will obviously build this so that when we screw it all together, material will be compressed. So in reality they overlap a little bit, kind of like in this computer model. But for the computer model's sake, this is not really like, let's say we would have to render this. This would be terrible. So I'm going to add another loop cut just for presentation purpose. Move this one down a little bit. Let me take a look. This is not ideal. Maybe bring this down a little bit. So I want to increase the distance and even it out between those loops. Yeah, no, this is a little bit better. And maybe this one move up a little bit, or this one down a little bit. Let's see how we do it. Oh, I see why. So GG actually moves and slides this one down to the original ring, and then G and Z can bring it back up. Yeah, that's okay. You see now here I have a bigger gap with those two, 3. So S and Z, Shift Z to bring this closer in, and then this one might have to go G and Z up a little bit. This one maybe can scale a little bit there. Oh, okay, good. This is really sufficient. We don't have to get it better. This is round, and maybe down there actually. This will be a problem. So if we, for example, turn on the threading, see that the threading has to somehow cut into the object. So at one point there has to be an entrance, and I think the easiest way to do this is by maybe building everything this way. So this maybe move down a little bit there, maybe one down and maybe one more, and then these two, S Shift Z, we scale away. So you see we're actually opening this a little bit. And then GG, we can slide it again. Different way to explain what this GG actually means. So I can move this one up and down, left and right along the axis. If I press G, I'm just in freeform move. If I press G a second time, you see I actually slide this point along an edge. And this also means when you select a loop, you can GG, slide it to the one side or slide it to the other side. There. Yeah, this is actually pretty good. Yeah, let's leave it that way. Maybe up here we have to do a little bit of fine-tuning. The stuff is intersecting too much, so maybe one step less there, and then it's the same geometry. So you see actually by adding a view level, this object shrank a little bit. And technically speaking, we would then have to also add a view level here. And it should then all fit again. Oh, where did it go? Oh, that was interesting. Okay, let's turn this one off for a second. There. Seems to be a little bug with that geometry. That's not good. Maybe just positioning this actually will help. Let's see, that should do it. Yeah, there it was. Oh, small thing actually sticks out. And we could also do interesting things like this. So you just cut actually a volume out of something. But obviously we just want everything in that area to be removed. Okay, and then you see when we have adjusted all these view levels, then it all fits again. And this is unfortunately a deficiency of the way how the technology works that Blender is using. Same with Modo. In Fusion, however, you only have make it smooth or make it flat, and there's just two settings, and the smooth view is perfect. It's like really like spot on. But you see, like if we match the numbers, then we don't have any issue. Okay, so this, for example, seems to look pretty good as the silicone insert. So what we can do now is actually, let's make this one blue again. Actually Control-C, Control-V over those colors, so it's a little bit easier also to see in the material selector. So you put your mouse over viewport, color field, Control-C, go to here, Control-V, there. Then you see actually these colors are applied here. Oh, and you actually should be diffuse. What the heck? There. Okay. Now this threading, we can actually cut out this silicone insert. And you see kind of like where the orange part intersects with the blue part. And that's all we need to have a secure lock. So instead of selecting all these objects, again, we can go and say U, difference. Now with the bottle we added, here we remove, and threading. Let's take a look. And what's this? This is interesting. Let's see if maybe we have somewhere some issues. Control N actually flipped and recalculated all the surface normals. So recalculate. This is also Control N. By the way, you also find all these commands, for example, normals, there, exactly the same. And let's leave edit mode, go into object mode, and take a look. There it is. There it is, nicely cut out. And let's see if we have enough of an entrance for the threading actually to fit in. Maybe in this case actually what we're going to do is this one we scale a little bit more there. Yeah, this is better. A little bit softer. I would like to have maybe a little bit crisper edges, so I could go to the mesh information and say auto smooth, maybe 30 degrees. Yeah, okay, and you see like those edges are a tick sharper. Perfect. Yeah, let's actually take a look at this with the cap. So that actually should work pretty well. So to make this obviously perfect, then we would go back to our main threading master. Sometimes I also call the parent part master. And we just turn all these on. Zup, zup, zup. Let's go back to the threading. Let's do a double check that there are no misaligned objects. And it seems this is actually pretty working. Yeah, good. Obviously there are some design flaws with it or some issues, but again, this is kind of like our first modeling exercise and the warm-up project, so we'll leave it at this.